So the first question is about just a straight up impulse question required to stop a moving vehicle. And so the formula shows that, well, if we can know our change in momentum, that tells us our impulse, which is the force times the time applied, but it doesn't want the specifics. We don't need to know exactly how much force or time, just the overall combination of force and time. So the change in momentum is the momentum final minus the initial momentum, which will tell us our impulse, which gives us our mass times velocity final minus mass times velocity initial to find the impulse. Our final is when it comes to a stop. So we have 2,000 kilograms times 0 minus the starting or initial 2,000 kilograms times 15 meters per second. And that's going to tell us our impulse, which gives us 0 minus 30,000 kilogram meters per second. And so that's our impulse. And our impulse kind of shows up like this. It could either be negative 30,000 kilogram meters per second, or, because the impulse is also given in terms of force times time, negative 30,000 Newton seconds. So I do want to show you something really quick about these top two units right here, how they relate. Recall force equals mass times acceleration, which means force newtons equal kilograms. That's supposed to be times meters per second squared. And now if we look at force times time, which is our impulse, that's newtons times seconds, which is kilograms times meters per second squared from newtons times seconds from time. And if you do the math, what happens right here is, well, this second is going to cancel out one of these two. There's two down there, that's why it's second squared. And we end up with kilograms meters per second, which is the same as momentum. So if we do force times time, that's going to give us a momentum value, and that's why the change in momentum can be measured by how the force times the time is applied. And just to review from yesterday, this overall impulse is the combination of force and time. We don't know how it's stopping. It could be gently applying the brakes for a long time with a small force. It could be slamming on the brakes, a medium stopping time and a medium stopping force. It could be hitting a brick wall, an instantaneous stopping time and a very, very large stopping force. But we don't need to know the specifics. We just know that the overall impulse in all three of those scenarios is the same. It just changes depending on how we apply the force and for how much time.